the question is, when we remove elements from our collection, is memory released and given back to the system, and will physically the imprint of our object uh, be changed, and so it will physically adjust its memory footprint and become smaller, as it probably should, as you know, as you would probably expect it as a programmer. The answer is yes, but it's not going to be done immediately upon each removal. Perhaps if you remove one element from the collection, it will simply be, marked as removed. Um, uh, but as you remove more, perhaps when you remove like half of your collection, then the array list may decide to remove, to reduce the internal storage from array of this size to just a half of it. So occasionally, the implementation of your collection will be making that decision for you. But yes, as you have a collection of elements and you will be removing elements from it, uh, the implementation will decide how and when to remove and release the actual physical memory and make sure that the size in memory is indeed reduced. So the answer is yes, but it's up to the container itself to decide how and when and what strategy is used. It's hidden from you. You're not controlling it. So you may say remove a couple of times, but it will make no real impact on the uh, physical memory. Again, the situation may be very different when we use array list or linked list. In a situation with linked list, that type of removal may be instant because there is no array storing the object references internally. But with my array, which is based on the physical storage using standard primitive Java array, there the strategy is going to be different. It's going to be deciding when to reduce the memory used by that array, and it may not be on each single removal, but once upon a time. Good question. Thank you. That's, I mean, because as programmers, we should probably be aware of how big the 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 memory consumption is when we attempt to use it, especially as we get those powerful, objects such as those generic collections. It's very easy to populate them with data, and it's also very easy to remove data from them. So perhaps we need to be aware of it, and we should be doing both. I think. Uh, Oftentimes, uh, collections get populated, but really don't change that much during their life cycle. Then it's okay just to you know, uh, um, delete the entire collection, and the entire memory then, of course, will be garbage collected. No question about that. So this sort of covers our conversation about the iterators. The next topic that I would like to cover today is related to new type of collection, which is a map collection. Collection that's using an interface. And I think somewhere here we mentioned the existence of I actually open an overview of Java arrays. This is a wrong handout. Let me see. This is, I think I had a link somewhere here. Yeah, collections and generics. Let me open this one. All right, so collections and generics, and on this list now, this is more recognizable. Um, let's talk about those two new types of collections, hash map and tree map. So the picture inside hash map and a tree map is going to be different compared to lists and arrays. And the difference is in the fact that what these collections store, instead of individual elements, they store pairs of elements. Basically, what happens is that these collections contain a key value, okay, some sort of like a key value, which logically points to the value itself, the value. Okay, so I'll just draw it as a pair. And if we have this type of thing, a pair of a key value, uh, two items, then I could wrap it in, in an object like this, right, as a pair, as something stored together. And then I could, sort of like multiply this in memory. And the hash map and tree map, these collections will actually uh, contain these pairs. So there will be a bigger box around all this, right? And this will be an example of a hash map or tree map. Why is this useful? In a normal collection, we just store values. We don't care about any sort of key. And there we have index to navigate to a particular, item 5 steps away from the beginning of our collection. Similarly to what we do with primitive Java arrays, with just a array basic type that Java provides. But here, the idea is that if you have a lot of values and they all can have meaningful keys, then instead of using any sort of index or search inside your collection, you may go directly as long as you know the key to get to your value. So it's like an index. This becomes your index and this becomes your data set. So you have some data and you have some index values. And as long as you know what the index is, for instance, you can use the user. Like, give me the flight number. Like so they say, DL123. And you try to access this container and say, do you have the key named the key that contains this value just typed by the user, and you may find out that the answer is yes or no. So if the answer is no, no such key exists, then you bounce back and tell the user no value was found for your key. Otherwise, you extract the value and proceed with that value. Of course, you can also remove elements by key, and you may also be able to search sequentially if you have to for particular values or particular keys and examine those things individually. But ultimately, the purpose of having this is to have some sort of a data a symbol table. So you have a set of keys. For example, you could emulate the behavior of programming language and create your own small programming language. There you may allow the user to create variables. So variables x, y, z will be stored as keys x, y, z, whereas the values of these variables 1, 2, 3, 4, 5, or whatever you're using to store will be stored as values. So the question is why we have those two, tree map and the hash map. And the answer is that we have the two of them provided. Display it side by side, right? Because the internally or physically what you get is the same thing. You get the key and the value pairs, and they're all stored. Um, and you have instant access, random access based on the key. But tree map, in addition to what hash map does, will also sort the elements by key. So if I'm using a string as my key, the type, then my values will be sorted by alphabetically by the values of my keys. If I'm using hash map instead of the tree map, then they will not be sorted. They will still provide you quick access to the value based on the key, but but the collection itself will not attempt to physically sort anything. So let's try using them, right? So let's try using them, and we can try to populate a collection. For example, so let's say the segment